Welcome back, everyone. In this video, I'm going to show you how and why we've converted most of our electronic devices to run from straight DC power rather than from power bricks and wall warts. So, if this is your first time here, I'm Jason, and this is our rig, the Everlander. My wife and I built this thing in our home garage, and since 2018, we've been traveling the world full-time. From hometown Canada, as far north as you can drive, all the way to the Arctic Ocean, where we headed south, through the United States, Mexico, all throughout Central America, and then we put it on a ship and shipped it to South America, where we've been traveling through Colombia and Ecuador for the last year. And unlike a typical camping trip where you can make do for a week or two without some of the luxuries of home, or you might even embrace unplugging from technology for a bit, this is our full-time home on wheels, and so we need to be able to power all of these devices without the grid. Now, of course, at home, most electronic appliances you buy are going to be plugged into an AC wall outlet, so taking these devices on the road with you requires AC power, and if you're just going to a campground where you can plug in, that makes it pretty simple. But if you're leaving the beaten path, traveling where there is no option to plug in, off-grid as we say, then the most common option is an inverter, powered by batteries, and recharged with solar panels. And that works just fine. We've been doing that for decades. On this truck, we have 1.5 kilowatts of solar panels on a pneumatic sliding array, and nearly 12 kilowatts of storage in our lithium iron phosphate batteries. And of course, we have a big inverter to power all of our cooking appliances, air conditioner, laptop, and all the other conveniences that need AC power. And that's all well and good, but unlike a short camping trip where you can get a reasonable forecast for good weather, or run the batteries down and then recharge them when you get back home, traveling full-time often puts us in climates or conditions which are less than ideal for solar production. And while our big battery can tide us over for a week or so if we're in bad weather, after a few years, it's quickly become clear that watts saved are watts earned. This brings me to the point of the video. Saving power by running our loads directly from DC, rather than taking DC power from the batteries, converting it to AC with the inverter, and then converting it back to DC through a power brick. Now don't get me wrong, inverters are awesome, and a very necessary component in full-time overland travel. But oftentimes the losses due to inefficiency are overlooked and not considered, and that's what I want to show in this video. A good example, which you would have seen in our recent videos, is our Starlink satellite internet. The power consumption from our batteries when running on AC power through the inverter, including the losses in the inverter, is about 60 watts. But when powering from DC directly, only 28 watts. About half the power is lost to overhead converting back and forth from DC to AC to DC.
Snip, snap, snip, snap, snip, snap!
Now, obviously, these losses are not linear. Our 1,000-watt kettle doesn't consume 2,000 watts through the inverter. The losses there are more like 10%, but those aren't the loads I'm worried about anyway. 10% for a kettle that runs for maybe 5 minutes doesn't amount to very much. It's the low-power consumers that stay powered on for hours and hours that really add up. Starlink internet, a laptop, Dyson Vacuum charger that gets plugged in and forgotten. Heaven forbid you're using a wall wart to charge your phone. It's these sorts of things that pull 100 watts or less, but need to be plugged in for a long time, and all the while the inverter is bleeding 30 or 40 watts in parasitic drain. The second reason I've made a push to power as many of our devices from DC as I can is to reduce our dependency on the inverter. For some of you who saw our first video, after we arrived in Colombia, our trusty steed of an inverter died, and we couldn't charge our laptop or run Starlink, and we felt pretty helpless without it. So, having the option to run these things on DC gives us some level of redundancy. Not that I'm expecting our inverter to die. I'm just saying in the last 5 years of travel, I've helped a lot of travelers, and I've seen a lot of dead inverters. So, let me show you a bunch of examples of things I've hacked to run straight from DC power and how I did it. First of all, let's look at the DC to DC converters we'll be using here. I've dug out a bunch of examples for a little bit of a show and tell session. First of all, there's these finned aluminum brick style. They're completely sealed from moisture and dirt. This is a 5-volt one, which takes our 12 volts down to 5 volts, I've been using for our Raspberry Pi that does all of our automation. There's another one in our DIY Android Auto navigation unit. And there's another one here in this USB charge station, which I'll show you shortly. This one's actually spare that I've been carrying since Canada, but I haven't needed it because I haven't had one fail on me yet. These are available as step up or step down in all sorts of voltage ranges and current capacity. This one steps up to 48 volts. This one steps down to 5 volts. Then we have these bare BCB boost converters. This is a 400 watt unit apparently. This one claims to be 1500 watts. I have a few of these installed. I'll show you here in a bit. And then there's the venerable and popular LM2596. I just ordered myself another box of 10 of these, and they're a step-down converter, which can handle about 3 amps, although I would never load them up that high, but they're great when you need an oddball voltage, or you're using it as a battery eliminator, and you need 8.4 volts. Probably seen me use these in the walkie-talkie video, but I've used them in lots of other things as well. And then there's DC to DC converters that are purpose-made specifically for the application. This one for ResMed, for example. So let's look at some examples of how we use these. The first one you have probably seen already was in our recent series of Starlink hack videos. If you haven't, you can click up here and see those and watch exactly how I converted our Starlink internet to run from straight DC power using the Dishy DC power supply, or optionally with these aluminum brick style converters. Next is our MoFi 5500 LTE cellular router. This one was really easy and more of an honorable mention than a hack. I just ditched the AC wall wart that it came with and bought the DC to DC regulator that MoFi offers. It takes up to 24 volts input and outputs stable 12 volts directly out of the included barrel connector. So super easy, plug and play. Next is my CPAP anti-death machine. Again, a bit of an honorable mention because I just bought the DC to DC converter offered by the manufacturer. It's a boost converter that takes the 12 volts and boosts it up to 24 volts that the machine needs to operate. Next is the Dyson Vacuum Cleaner. A favorite among overlanders. As you know, it comes with a typical wall wart, but it only charges at 22 watts and takes hours and hours to charge. So it's a good candidate to convert to DC power, and because it conveniently fits right here underneath my CPAP machine, and it uses the same 24 volt power, I just ordered the same connector cord from Amazon and spliced into those wires from the CPAP machine, and I can just plug it in there and it can sip away at the power until it's charged up, and then I verified that the power consumption drops to 0. Next is this 27-inch computer monitor mounted here on this wall. We use this to monitor our solar production and consumption statistics, as well as display temperature, water levels, that sort of thing. I also use it as a second monitor when we're editing videos or doing other intensive computer work. It's also great for Netflix and chill. I was very careful when choosing a monitor for this application because at that time, some of the models had an AC plug directly in the back of the monitor, and that would have made it a lot more difficult to provide our own power from DC. So that was one of the reasons I chose this model, because it had an external power brick that output 12 volts DC. So I simply cut off the cord to the brick and soldered it to one of these 12 volt regulators. Now admittedly, if our goal is to save power, this would be a big waste of power if I just left it on all day showing this dashboard. So I've actually written a little script that powers it on and off using HDMI commands in software, and they're triggered by the motion detectors in the room, which control our lights and everything else. And because it's controlled by a script, it only comes on automatically if our battery state of charge is over 70%, and if it's daytime. Other than that, we need to turn it off and on manually. Next, let's talk laptops. This is probably the most common reason people get an inverter, and it's one of the things that rarely comes with an option to power it via DC. And in our case, it's powered up for many, many hours a day, thus a prime candidate for DC to DC conversion. This is my big powerhouse Everlanders brand laptop, and it's no slouch. It is a 12-core i7 RTX 2060 and 3 SSDs, and it can pull a lot of power when it's crunching. And of course, it came with a chonker of a power brick. This thing's rated at 180 watts, 19.5 volts, 2.3 amps. So let me walk you through how we power this laptop from DC. We need to be able to boost the 13.5 volts from our batteries up to the 19.5 volts that the laptop needs. And don't forget the watts. We need all the watts. And so we're going to use this big boy DC to DC step-up converter. I've used these for all sorts of things in the past. They've worked really well for me. The listings say they will take 10 to 60 volts input and output 12 to 90 volts, as long as the output is higher than the input. They claim a maximum power rating of 1500 watts, which is more than enough for this 200 watt laptop. Do I think this will last very long at 1500 watts? No. My rule of thumb for such Chinesium products is to derate by half. Your results may vary. I won't get into it. So anyway, let's give you a practical real-world example, start to finish, how to wire this thing up. It's really simple. We already know from the label on the back of the power brick that we need 19.5 volts, and it does indicate positive on the inside, negative on the outside, but that's always good to check. So we'll simply take our voltmeter here and grab the power cord from the original power brick and confirm negative on the outside, positive on the inside, and no surprise, 19.523. Next, we need to find the appropriate connector for the laptop or whatever device you're working with. In the case of this laptop, it was actually very easy to find because it was the exact same connection that's used on the Dyson vacuum cleaner. So I already had a spare cable from the 2-pack, which I ordered previously. But if you have a proprietary connector or something super weird, I have a solution for that too, which we'll get to here in just a bit. Okay, so now we're ready to wire up the boost converter. Our input power goes in here, and I'm just going to use this little pigtail wired up with an XT60 connector so that I can easily connect it to this little extension I have handy here. These are my favorite little high power connectors, but I'll get to that later. Okay, let's power this thing up. Get the voltmeter out here. As you can see on the input, we've got 12.6 volts, and on the output, 50.5 volts. That is too many volts. That will make your laptop go boom. So we need to back off this little screw here on this potentiometer until we get an output that reads 19.5 volts. This boost converter also has a constant current adjustment here. You can use this to set the maximum allowable current that the boost converter will put out. I might get back to that, I might not. Then there's also a undervoltage protection set screw on this trim pot here. This can be used to set the battery voltage at which the power supply shuts down, preventing you from over discharging your camper batteries. So hopefully you guys can see this here at the back. The undervoltage protection LED is lit. We're coming in with a voltage of 7 volts and coming out with 7 volts. But as I turn this voltage up, once we pass 11, you can see that the output voltage jumps to 19.5 volts. On that demonstration, I used my DIY adjustable power supply, but you don't need such a thing. You just need a battery that's at the voltage you want it to shut off at. So just discharge your battery till it's as low as you want, and then adjust the screw until the LED comes on. So now we've got the boost converter all set up, it's time to connect our laptop connector. Now, just to give you guys a little explanation here, I've actually lengthened the cable that mine came with, which is why the wire goes from black to red, as you'll see here in a second. I used some high quality silicone 12 gauge wire and then terminated it properly with some eyelets. Don't go and chew off the insulation and twist the wires and jam them in and hope for the best. Especially in an RV environment, things are shaking and moving. You want to make sure you have really good connections. Okay, there it is, all wired up, ready to go. Now, of course, you'd want to double check your work, so I'm going to power this up. Get your voltmeter with the new connector there. Negative on the outside, positive on the inside, and double check. 19.5 volts. I'm going to plug this in. As you can see, battery status 32%, now plugged in. And now we'll double check the outputs at the boost converter and make sure we're still at 19.5 volts under load. Now you can see here I've discharged my battery down to 32% with all this playing around. The laptop wasn't plugged in here, but now it's down to 32%, and that should be putting this boost converter under a little bit of a load. So it's at this time that the voltage would sag if it was going to, and it's still at 19.5. I didn't need to adjust anything. Of course, you can't just have a power supply bouncing around loose like this. I have mine mounted in the compartment underneath our table, and then the power wire, HDMI cable, and USB-C hub cables all come up through the center of our table leg and out this little hole here. And then when they're not in use, I can just bundle up the wires, stuff them down the hole, and put this little cover over the hole. Well, that's all well and good, but what about smaller laptops? Well, since USB-C standards have the option to negotiate 5 amps at 20 volts, about 100 watts, it's possible to power newer, smaller, more efficient laptops from USB-C, for which there are plenty of DC to DC options out there. This little cutie patootie laptop, for example, will charge from this 12-volt USB-C power adapter. Unfortunately, I'm only at 5 volts, so about 15 watts with this little adapter, but the battery in this thing can last so long that I can charge it overnight and then run it most of the day without plugging it in. But there are much bigger USB-C power delivery chargers available, like this one, for example. I don't have it, but it looks decent. The link is in the description. But what if you can't find the power connector for the device that you need? Well, I just so happen to be the proud new owner of just such a problem. This is our brand new network attached storage device, or NAS. It was provided to us by one of our supporting channel members named Chris. I asked our AI computer what he thought he looked like, and this is what the algorithm came up with. The nice thing about this particular NAS is that the power brick that it comes with outputs 12 volts. The problem is it's a 4-pin DIN connector. And while I understand the manufacturer didn't want you plugging in the wrong adapter from the wrong device, or they may need this many pins for that much current capacity, but I'd rather have a more standardized connector, so here's what I'm going to do. I'm just going to cut the cord off the power brick and install my own connectors in there. These are the AMAS XT60, and they've become my standard connector for everything lowish voltage DC with high-ish current, and I really like them because they're a soldered connection, so you can take them off and replace them or change them around as often as you'd like. So all I'm going to do here is just solder a pair onto the original power cord, making sure this end is female on the source and this end is pins on the load, and then I can always reconnect it back to the original power brick if I want, or connect it to a DC power supply like this. I hope to do a whole video on this NAS and how we're going to use it for video editing while on the road, but we'll save that for another video. Next is our 3D printer. It lives back here behind my seat cushion, and I made a whole video on this printer and how I installed it into our overland truck. Basically, I just removed the grid power supply that it came with and powered it with DC. That was a few years ago already. You can check that video up there if you're interested. Turned out to be pretty popular. But anyway, it's being powered by the exact same 1500 watt boost converter that I showed for the big laptop, just that it's set to a higher voltage of 26 and current limited to 15 amps. As you can see, I've got the same XT60 connector on there as well. This boost converter has been installed and running well for 2 years already with no issues. And I'm usually printing something at least a couple of times a week, so it's not like it's not being used. Now in the last Starlink video, I had a few comments and questions regarding sourcing your 12 volts straight from your vehicle's 12-volt battery. They ask, 12 volts is 12 volts, isn't it? Kind of. If it was just a small motor, like a fan or a pump or some LED light strips or something, I'd say yeah, go for it. There's not much for electronics that can go wrong. But if we're talking about complex and expensive electronics, without filtering for the harsh electrical environment in a car, you probably get away with it, but there are some risks. Not only can automotive voltage vary widely between 10 and 15 volts when starting and charging, but also there's big risks of flyback voltage spikes. This happens when a large inductive load is de-energized. A good example of that is a large motor or solenoid like the starter. This can cause reverse voltage spikes in the car's electrical system, and while we don't charge from our engine, we still see spikes from our air compressors and larger air solenoids. And while I've mostly snubbed them with fast-acting Schottky diodes, it's still not worth the risk in my opinion. It's much safer to use a regulator to filter most of that out and keep the voltage nice and stable at 12.0 volts. I'll get off my soapbox now. Let's skim over a couple more DC conversions here. Next is the UV sterilizer in our water filter system. It originally used to be 120 volt, 6 watt wall wart, but we would need to remember to turn on the inverter when we were going to take some water, and then remember to turn it off when we were done to save the bulb. But recently I converted it to run from an old 12 volt fluorescent light fixture ballast, and I also tied the controls for that into our water flow meter system. So as you can see, as it detects water flow, it turns on the UV bulb, and then a minute later it turns it off. This should make sure that we don't use up the 9,000 hour lifespan of a UV bulb prematurely. Now that was a members only video, but you didn't miss much. Next is this little cordless Dremel tool, perfect for trimming dog toenails as well as honing out cylinder walls. It came with a little 110 volt to 12 volt wall wart that went into a little charging base, and it had really poor contact and it wouldn't stay seated, and I needed to jiggle it to get it to charge. But since it runs on a single cell lithium and all of the charge logic is internal to the tool, I just tacked another XT60 onto the bottom here, and I can just plug that in to any of our little XT60 12 volt outlets. That was all covered in a members only video some years ago. Again, you didn't miss much. And of course, the easiest answer to most rechargeable things these days is to simply use USB rechargeable devices. And for that, I've made this dedicated USB charge drawer for all things USB. As you can see at the back here, another one of those 5 volt, 5 amp regulators that feeds into a USB hub. And from there, we've connected all kinds of USB cables where we can charge all kinds of slow USB things. Things like flashlights, headlamps, battery chargers, e-readers, hair straighteners, basic slow charging things. And I've got all kinds of USB cables in here. USB-A, micro USB, mini USB, USB-C. Most things seem to be going that way these days. Then here on this side, I've got another USB charger. This is a 6-port USB charger that supports QC3 quick charge, but importantly, not PD, power delivery protocols. It's actually on sale right now, half price at Amazon, link in the doobly-doo. It's just powered by a cigarette lighter, and I've cut the end off and just hardwired it in here to 12 volts. I actually have a second one of these 6-port chargers that I normally use in the front driving cab too. They work really great. Then lastly here, I have 2 USB wireless charge pads. We got these from Costco in Canada years ago, and they just take 5 volts in here, and then we can just throw our devices on here before going to bed, and they're all charged up in the morning. And it's not just phones. We have lots of camera and video equipment that's USB rechargeable as well. Even lots of stuff which was not originally intended to be USB rechargeable. I've found USB chargers aftermarket for most of that stuff too. Now I realize some of these examples are pretty specific, and perhaps you don't have this exact Everlander's laptop, 3D printer, or camera gear. Still, I hope I've sparked an idea and at least given you a head start on how you can run your devices on straight DC power, possibly even negating the need for an inverter altogether. I also realize there's going to be some Keyboard Commandos down in the comments that didn't even make it this far in the video and are very kindly going to inform me of something I would never have thought of on my own. and that is DC to DC converters are not 100% efficient either. And while that's true, perhaps only 90 or 95% efficient, the conversion only needs to happen once. We don't need to convert back and forth, DC to AC, back to DC, with losses in each conversion. Furthermore, the closer the input voltage is to the output voltage, the more efficient they can be. This boost converter runs all day and is barely armpit warm. The temperature controlled fan doesn't even come on. Compare that with the original 120-volt wall wart brick. It gets uncomfortably hot after just a couple of hours of use. That's a big difference in efficiency, if you can feel it. So there you go. If you have any specific questions about something you want to run on DC that I didn't cover, let me know down in the comments and I'll try my best to help you out. I've put all the links to all of the DC to DC converters that I use, as well as my favorite DC powered soldering iron and the XT60 connectors. If there's anything I've missed, let me know down in the comments and I'll try and find you a link. As always, a massive thank you to our supporting channel members, especially our Elon tier member, Furious George. He's once again putting up the pesos this month for our Starlink service. Thank you very much. It's the support of these fine folks that lets us make the videos I want to make and not need to find a segue to tell you about our sponsor. As always, thank you so much for watching. Thanks for your comments. See you next time.